In this question, we're being asked to draw the full structural formulas for each of the following compounds. So for the first compound there, 2-methyl-butane, we begin by drawing the longest chain of carbon atoms. That comes from the end of the name, the part that says butane, and but means that we have 4 carbons in that longest chain. The ane means that it's an alkane, which means that we have single bonds between those carbons. Now what I need to do is add my branches. So to add my branches, I need to number my carbons first. So I'm just going to number them. And now I go back to my name and look at what my branches are. So on the second carbon, I have a methyl group. So 2-methyl. So I go to my second carbon and I add a methyl group, CH3. Then what I need to do is just fill in my hydrogens so that I have 4 bonds on each carbon. So we'll add 3 hydrogens there. So that carbon now has 4 bonds. On carbon 2, we'll add 1 hydrogen. On carbon 3, we need to add 2 hydrogens. And on carbon 4, we need to add another 3. And that is that finished. So that is the full structural formula of 2-methyl-butane. The second one here now, so part B, we're being asked for the full structural formula of 2,3-dimethyl-butane. So again, we're going to start with the longest chain of carbon atoms, which is 4 because we have butane. So 1, 2, 3, 4 carbons. And because it's butane, it's an alkane, so again, single bonds in between. And now we need to go for the branches. So I'll number my carbons. 1, 2, 3, and 4. And have a look back at the name again. So 2,3-dimethyl. That means I have 2 methyl groups. One on the second carbon and one on the third carbon. Now it doesn't matter whether I draw those methyl groups above carbon 2 and 3 or below carbon 2 and 3 or one above and one below. That doesn't matter at all. Because we can rotate around these bonds, it doesn't matter which way we draw them because they're constantly shifting anyway. So my branches are in. Now what I need to do is just fill in my hydrogens to make sure again that every carbon has 4 bonds. So on carbon 1 I need to add 3 of them. On carbon 2 I need to add 1. On carbon 3 I need to add 1. And on carbon 4 I need to add 3. And now we have our compound 2,3-dimethyl-butane. For the third one, part C, we're being asked to draw the full structural formula for cyclohexane. Now hexane normally looks like a straight chain of 6 carbons with single bonds between them. But because we have cyclo in front of it, that means it's going to be in a ring structure. So if you think of 6 carbons in a ring, it will look like a hexagon. So I'm going to put my carbons in and join them with single bonds because it's cyclohexane, an alkane, all single bonds. Whoop, that's a single bond there. And from the name we can see we've no branches. On your course you'll find that you'll never have branches with cyclohexane. You'll never have 1-methyl cyclohexane or 1,2-dimethyl cyclohexane. It'll just be cyclohexane. So you don't need to worry about that getting too complicated. You just need to know this structure. So to finish it off, we need to fill in our hydrogens. And again, every carbon has to have 4 bonds. So if we look at the carbon at the very top of our hexagon there, of our structure, we see it has 2 bonds. So I need to have 2 more bonds. So add 2 hydrogens on. Same with the next ones. So hydrogen and hydrogen. We need 2 on each to make sure that every carbon has the full 4 bonds that it needs. And it needs those in order to obey the octet rule. So every carbon there has 4 bonds, 2 hydrogens, and then 2 bonds to other carbons. And just to note, because this is a cycloalkane, it's in a ring, it doesn't follow the normal general formula of an alkane. We know the normal formula is CnH2n. sorry, there's something wrong with this pen. 2n plus 2. So there should be twice as many hydrogens and another 2 as there are carbons. But we can see from this structure here that we have C6, so 6 carbons, and we have H12, 12 hydrogens. So it doesn't follow that general structure. Okay? That's just something to note about the cycloalkanes. They don't follow that structure. Now, lastly, I'm going to move down a good bit for this one, but it's 4-ethyl 2,2-dimethyl heptane. Don't let it scare you, it's not too bad. What we're going to do is draw the parent alkane first. So the parent alkane is heptane, so that's 7 carbons in a row. So I'm going to draw 7 carbons in a row. 1, 2, 3, 4, 5, 6, 7. That's hept, and because it's an alkane, they're all singly bonded to each other. Heptane. And I need to do my branches. So before I do my branches, I'll just get my numbers in. So 1, 2, 3, 4, 5, 6, and 7. Now, to the branches, we have 4-ethyl 2,2-dimethyl. So the 4-ethyl means I have an ethyl group off the 4th carbon. So an ethyl group is a C2H5. There's 2 carbons in it. Ethyl. That is a 5. Now it's a 5. And 2,2-dimethyl. So I have 2 methyl groups, dimethyl, and they're on the 2nd carbon and the 2nd carbon. So that's all my branches in. Now I need to add in all my hydrogens. So in order to ensure that every carbon has 4 bonds, and that's our full structural formula for 4-ethyl 2,2-dimethyl heptane.